Yo.
Hey, Jason.
How's it going?
Sorry, my bad. I'm trying to figure out how to keep the regular YouTube channel live. Although, I mean, we're all going to move to the Slack channel, so I think it's better to the repo. I'm going to share the repo. All right. So, welcome everybody. It's really good to have you all here. We're going to do our first workshop. As you know, we also have a free Python course. We don't have an estimated date for that one yet. So we thought maybe we can make something shorter, just one day as today, a few hours, and hopefully show you something that can be useful for your day-to-day activities to help you kickstart your goals, if you want, or your activities with data science or data analysis in this case. This is the format of the workshops. If you folks like them, we can also plan on doing more, and ideally we can plan on doing them some, like, for example, a Saturday morning, so we have a little bit more time. A Thursday night, or any night actually, we cannot have more than 2 hours, so maybe we can have 3 hours on a Saturday. It'd be much better for the experience. The idea of today is to give you a quick overview of the data analysis space of Python in general, and to, again, help you get started with it, or maybe you already know about it. So we know that you all have different backgrounds, so we'll see how it goes. Slack channel is open, so any questions, just post them there. Jason will be moderating it and talking to my ear in case there's any question I should like attack before we pause. The idea of today is to make these highly practical. So we were going to show you a few things, and then we're going to stop and we're going to give you the tools and the resources that you need to work with those topics. There will be a few activities for you folks to work with. So I'm going to get started. I'm going to ping you all in the Slack channel. Oh, hey, Amy. Is Amy around? Oh, I wish we had all the Verizon folks. And so let's just get started. I'm going to show you really quickly how this thing works. I'm going to just share my screen. And we are going to get started. There you go. So again, the Slack channel is open. So just, if you have any question, post it there. This is a repo that we're going to start working with today. We know that all of you have different backgrounds, so it's really hard for us to just get on something that's going to be useful for everybody, or, I mean, give the right instructions that will suit just anybody. So we have set up everything for you to use, to like walk these at your own pace later if you need. So hopefully, if something is not entirely clear, with questions plus a recording plus the repository, you can work it out later. All right, there is a good explanation of how to set up all your notebooks in this README in case you have to do that later. For now, I'm gonna do it again, just right for these workshops, so you can just follow along what I'm doing. The only thing that you need is with your Azure account, the one we mentioned in the email, you just need to create a new library, right? And in the GitHub tab, put these right here, what we mentioned in this README. So you can just follow these along with me, right? That's the idea. That analysis workshop right here, right? It's right here. I'm gonna copy and paste this thing right here. Right, so it's gonna be github.com/rmotr/data analysis workshop. That's the name of the repository. And that's it. You can also give your library a name. I'm gonna do workshop testing, and I'm gonna give a unique ID here, workshop testing 1. And that's the only thing that you need to do for today's practice. And this is gonna give you a full Python environment with your notebooks working, nothing else to install, nothing else to work with, just this thing right here. So then you hit import. It's gonna take some time, but it will finally load all the notebooks we have in this repository right here. All right, so that's the only setup process you need to follow for today's workshop. And that's why we wanted to just do it with you right here. We don't like to give you too many things to install. Just a quick comment here. These notebooks have like a full Linux environment underneath, so you can be really certain that these will satisfy most of your needs working with these simple notebooks. If you, of course, need to do more advanced work, you might need to install your own libraries. For now, this is more than enough. I'm going to close this testing one up. I have these one already created. And again, I'm going to just start with what we have planned for today. And at any moment, any questions, just let us know. Oh, David, Yahas, hello, folks. So good to see ex-students around. So the first topic we have is the introduction to Python. That, to be honest, this is a blank notebook. We don't want to waste a lot of time talking about Python because there are many resources out there you can use. We actually have a post in our blog that has a list of 3 really good free books for you to get started with Python if you don't know it already. Again, different backgrounds. So we know that some of you have background in programming, maybe with other programming languages. You're good with JavaScript or Ruby, and you need to transfer that knowledge back to Python. We know that some of you might just be getting started with Python. We know that some of you are, I don't know, you know the domain, the science domain you're working with, you're biologists, you're working in finances, you're and that's the experience we have from our students, right? So we have a wide variety of backgrounds, so that's why it's hard to find a common ground in terms of what we're going to talk about Python. What I would like to talk about in this case about Python is how good it is to get started with data analysis, and also this big advantage of being a broad general programming language. And it's something pretty unique to Python, because Python is going to be, of course, useful to do data analysis and data science in general, also machine learning, for example. We have people, I don't know if Lou is around. Lou, I don't think you're around. But we have students working in high-end finances, right? Working with real money every day. And they're working with Python plus R, of course, which is a really good programming language too. And that's, of course, a reality, you know it. But aside from data analysis and data science in general, Python is a good programming language for other things, you know? So you're far away from just doing Django work, web development, you know, working with Django or Flask to create web application, mobile APIs, you know, so you want to create a mobile application and you need a backend to create an API for that. Or maybe your main goal will be working with data science, but at some point you want to publish your results, expose those results, or build an API so people can consume that data you have somehow analyzed. And for that, to work with. I mean, it's a big advantage to have Python because it's just the same language, same tools, same environment. I'm going to leave this notebook open right here. If you have questions about Python, if we see any question that it's Python related, I'm going to just jump here, and then I will commit all the things we've explained here and push them. And this is going to be kind of an on-demand lesson, right? Whatever you need about Python, we're going to put it here, and then it's going to be public. For now, let's just get started with Pandas. Pandas is probably the most popular library to work with data in Python. It will nice and quickly work, especially with tabular data with Python. And it has a few important series, data frames, panels. You're gonna see series and data frames today. And of course, you will read about this everywhere. What we're gonna start with is showing you how all these things work. For some of you, this might be the first time that you also work with a Jupyter notebook, right? So don't be scared about this. This is a really convenient way of working, executing your code with a Python backend. So it's just working here in your browser, but behind the scenes, this is run by a real Python compiler. So it's pretty convenient. Probably the only command that I need to show you is if I type Command Shift P, or probably if you're in Windows or Linux, you can do Control Shift P. You will get this view that it's the command line explorer, it says. So if I'm going to, of course, tell you a few more things, but if you forget how to do something, you can just bring this command palette or explorer, and it will show you what you need. So one thing, how can you run code with this notebook? So for example, here, I have just created a new line, a new row behind that, and I can just do simple Python work here. For example, computing something. You know, I can create a list with numbers, and it's just gonna work. And I'm gonna print L, for example. So this is a regular. I'm gonna increase the size of this a little bit. There you go. So this is just a regular Python, again, interpreter. How you're gonna run your code here, there are two main commands, right? So one of them is gonna be control the return key, run cell. It's right here, run cell, and I think is this one. And it's just going to run that particular cell. So it's control and the control and the return key. There you go. Or you can also do shift and the control key is going to run it and it's going to select the next after that one. You need to know to get this thing going. Have doubts or you forget about something, again, you can do command shift plus the character P, and you will get this command explorer, or this can of course be replaced with control for Windows, and that's it. You can run all these things right there. Everything else you will just get familiar as you make progress with this. So let's get started. I'm going to import pandas. This is a tool that we'll be using. And again, the idea is to show you really quickly how this thing works. The type of data that we will be working with is right here. Is you have access to this. By the way, when this sign is running, there you go. Just executed it. And this is the first type of data that we're working with. And as I told you before, this is tabulator data. You will feel that it's really close to a simple spreadsheet in Google. So this is the first type provided by pandas. So you can see I'm doing import pandas as PD. It's kind of an alias. It's convention. You can just do import pandas series. Again, it's a convention. We usually do PD. And you can create these type, pd.series. And this looks a lot like a regular Python list. It's actually being created if you highlight You know, if you're just zooming in the type, in the original object that it's creating the series, literally it's a Python list. And we are now creating these pandas series. And what does this mean? Is that we are creating, or we have like a brand new data structure that it's this series. The original data structures or collections were used of working with in Python, right? So in Python, we work with lists, we work with dictionaries, tuples, sets. And for data analysis in general, we will start using these other data structures or collections provided, in this case, pandas, because they're going to be a lot more efficient and a lot smarter, right? They are going to be just plain old smarter. Means this object is using NumPy, which is, we don't want to, on purpose, we don't want to talk a lot about NumPy, but basically is performant, efficient library that will make these things closer to C Python, to C code. You know, C, like the C programming language, machine efficient code, an interpreted programming language. So it's not really performant for numeric computations. NumPy will give you that machine level code. It's going to make things a lot more efficient. And by using this series type, again, it looks a lot like a regular list. You are getting all these amazing power of NumPy. So to get started, we're creating this series. I can assign this to S, and I will create a new row here. And it's going to be smarter because we can also do a few operations. For example, I can do something like 3, for example. And what it's going on here is that it's kind of doing a regular vector operation, like multiplying a vector or a one-dimensional array and a scalar, you know, a traditional, more mathy operation. If you remember about linear algebra, you will know what I'm talking about. So all these sort of array matrices operations will be native to pandas, and again, NumPy, because pandas is using NumPy behind the scenes. All right, so this is something to keep into account. It's going to be a lot more efficient. So I'm seeing a question right there, and it's a good question spec in the channel. You don't need to have it. We're gonna, of course, point you to that whenever we have the activities to work with. Again, the idea of today is to make a highly practical workshop. So first thing, this is a series. Now, it looks like a list when we create it in this way, but actually, this series looks more like kind of this structure. And this doesn't look like a list. Only these values. If I could flatten these values, if I could express these values horizontally, right? 7, picture if I do 7, 10, 11, 11, 12, these now looks like a list. In this case, these values don't look like a list. This whole structure like a list. So we're gonna see why in a second. And it's usually the biggest source of confusion with pandas, because everybody thinks simulates a list, when actually, I'm just going to say it actually simulates a dictionary. We're going to see why in a second. So all other thing that a series can have is a given name, and this is going to be useful for later when we use data frames. It's just putting a name to a given series. And as you can see right here, it says the name of the given series. Also, I haven't mentioned this before, but we used to have this D type right here. And that's because pandas is kind of introspecting or analyzing the values that you're providing for your series, and it's finding the most efficient data type to use. In this case, using an integer 64, and these can differ based on your computer. You know, if you have a different computer, you may have a different data type here. What you have to be sure about is that Pandas is trying to look for the best one. You can, of course, change that. So why am I saying that a series, it isn't a list, it's actually closer to a dictionary? Because This, what you have right here, I'm gonna also increase the size of this. This is a series. A series is gonna be a given list of values. That's fine. Up to that point we saw before. But each one of these values is going to have an associated index. That's the name that Pandas gives to it. And that index looks a lot like a key in a regular Python dictionary. So if you remember about your Python dictionaries, and we can use this one right here, here, it's going to be, if I'm representing these temperatures, I'm going to use Monday, it was 7 degrees, and Tuesday, 10 degrees, I think. So now, where is it? This dictionary, right? Look like this regular table. And that's the underlying data that Pandas is trying to represent with a series. It is a bunch of values. That's the important information you want to keep track of. But each one of these values has an associated name, an associated key or index, whatever you want to call it. It's a label to associate to each one of these values. So you don't have just random values out there. You know, if I give you a regular Python list and I give you something like 10, 11, 11, 12, you say, but I don't know which day each one of these values represent. Is this thing starting on Sunday maybe? Is this, or is it actually Monday? So you have to provide extra documentation. You have to say to you're working with, you have to say, hey, look at this list of temperatures, and please be aware that we're starting to count on Monday, so the first value is going to be a Monday. You have to give a lot of information. With, or better, with a Panda series, you have that value aggregated. I'm going to show you why. If I execute these right here, you have like these, which again, it looks a lot like this spreadsheet we have right here. Temperatures in San Francisco, and we have the name of the series, the indexes, and of course we're matching by position, first index with first value, second index with second value, etc. Makes sense? I don't know if you, let me see if, I think, yeah, there you go. So if you folks have any question, you know, Jason is handling that in the channel. So why are we going to start working with this series? As I showed you before, they're going to be smarter and a lot more efficient. And oh, by the way, when you see that I'm creating this regular object right here, by default, each one of these, by default, each one of these rows, whenever you execute them, will give you the final value return. So in this case, if, for example, I instantiate a list variable that's not returning anything, so you will see that the output of that, if I would like to inspect whatever I created here, I just need to put that thing at the end. It's going to show you that, which is pretty much the same thing as doing print L, right? It's pretty much the same thing. It's a little bit better to just do this output, just for you to know it. So this, again, it's going to be like this table right here. You have indexes on the left, you have values on the right. The important information are the values, and this is something that we also want to stress when we teach about Python dictionaries. The important information is the value. The index is just documentation, to say, you know, the index is of course also important, but it's just an addition. The important information is always the value you're trying to keep. And you can separate those with either, for example, values. You can do dot values, or this given temps variable dot or series, right? Index. And you will see that these two are different data types. This is a numpy array, and this is a pandas index, right? Which is also a numpy. It's backed by a numpy data structure. All right, so what's cool about these, and I have this described at the bottom. I'm going to execute these right here so you can see it again. And what I'm going to do is just do this describe at the beginning so you can see all the cool things you can get Python series. So for example, you get the count or mean or standard deviation of the whole distribution of the whole set of values or that data that you provided, right? Just out of the box, you do dot describe, and you're going to have either the quartiles and max and min values, etc. And you can use each one of these as individual methods. So as you can see right here, I can give me the mean or the maximum or the minimum value for each one for that particular data set. So that's a really cool thing about a pandas series. And of course, you're going to see a few more things more interesting, at least when we talk about data frames that are basically series. So how you're going to access these values? Well, there are different ways of accessing them. And what you will find here is that series work with, of course, the regular index that they have. So if, for example, I can say, I need the temperature, the Monday temperature, right? Or the Tuesday temperature, right? So you're just referencing the index, right? Or you can also reference these things by an integer auto-generated position, right? So 1, 2, 3, like this thing right here. And now it looks a lot like a list, right? So this is similar to a sequential list. So the first temperature right here with the numeric position 0, it's going to be 7, and the second one with numeric position 1, it's going to be, I'm going to show you, 10, right? And the way of getting these values is with the ilog attribute. So by default, if you have a series, just a plain old series, the one I created before, I'm going to put it again at the top here so we can keep it on the screen. There you go. If I do, let me do header. There you go. Toggle toolbar. There you go. No. All right. If I just do the variable that I have created and I try to access it like a dictionary or a list, I just directly access the given index. Of course, what I'm referring is the series index. But I also can do like a numeric, right, accessing with the ilog attribute. So this is an attribute and you access it by the position. What you will see is that actually what is going on below, like behind the scenes here, is that we're using the log attribute, right? So this is basically translated to this call right here. So in the truth is that you're actually using log and ilog, right, to access each one of the elements in
We
your
got two questions in the chat. If you want to read.
So you want to read them?
No, just you can read them in the chat.
What? But wait, which?
Okay.
Which
does a series have one set of values, like one set of keys with one matching set of values? That's the first one.
Really good question. So something really interesting you're gonna see with series and data frames in pandas is that these indexes can actually be multi-indexes. That's the name they give. So somehow you could do something like all these things are gonna be January, for example. So you can have like a 2-level index and that is really advanced. I'm going to collapse these ones. So you can have, and if we format it correctly, where is it? Right here and right here. So you're going to have like a multi-index. That's the name they give. So you will access, and of course you will have pretty much the same thing here for February, right? So it's going to be February. So you're going to have that these two things will be the index of these values. You're going to say, give me all the temperature from January. That actually will give you this thing, and then you can index that by the given day. So pandas does have that capability. We're not going to use it today because it's a lot more advanced. We have an example for data frames if you folks are interested. In these same notebooks. I don't know if we're going to make it in time, but it's right there. But the values will usually be just one value. Of course, that these objects that you're using to create your series can be, where was I? Right here, I'm going to create a new one. I could create a series with more complex types, right? So I can create this series with tuples inside, right? So something like that. 4. So in that case, you're gonna store more elements inside. And this is not something we do all the time. We actually use other constructs, but I just want to show you that you can pretty much do it.
The other question was, how do you write like percentiles like 60%? I think maybe they're referring to when you did the describe, how there was 50% and 75%. How do you call those methods? Maybe? I'm not sure.
You mean like to access?
I'm not sure. Maggie, can you elaborate? We'll come back to that one.
Yeah, so you will probably use this method if that's what you folks are asking for. You will just use quantiles to get values. Oh, I know why, because the describe one. No, sorry. Yeah, I actually this is what you were looking for. Yeah. So yeah, the describe one is gonna divide it in the most common quantiles: 25%, 50%, 75%. But of course, you might, and that's, I understand the question now, you might want to get them, you know, like 15%, you know, a completely arbitrary value. You will just use this method right here, quantile. That's fine. You don't have to stick with these ones, of course. You can also do aggregations that we're going to show you later. Values up to a certain point, and you can say, for example, 25%. Give me the first 25% values, right? The first values up to the 25% of that distribution or that sample. And then what do you need? Do you need, you're doing a cumulative sum, or you want the average or the median. So you might perform different operations with that subset of values, in that case, that quantile. All right, so we were using lock and ilock to get values out of a series. Remember, we treated, I'm gonna go back again to our previous one, we treat a series like this simple table. And we're doing lock to get things by the index, and we're doing ilock to get things by the numeric position of that value. So another big difference with Python dictionaries is that these values are ordered, right? So they have an actual order. Dictionaries in Python, they don't have an order. So you can also, you will see that you can get elements with different accessors. So for example, you can get many elements with a given set of indexes. So in this case, you're going to say, give me all the elements that follow Monday and Wednesday. Oh, no, sorry. Actually, and Wednesday and Sunday. There you go. So you're accessing basically this whole table by a set of indexes. And you will see that what you have inside is another list, right? Or a list actually inside the regular attribute accessor right there. So you're doing, as you can see right there. And what's the return type? It's actually another series. It's like, is that it's always returning a new either series or data frame, whatever it's matching that value. And it's like, it's in place in this operation. It's like creating copy, duplicate it, creating a copy. Then let me remove this one, that one. I'm gonna delete. There you go. And that's the result that it's actually giving to you. It's another series. So you will see that this is a really common behavior for pandas. It will create new objects instead of replacing, or modifying the original ones you had. Let me delete one so we don't get confused. That's all. All right, so another thing you can do is also do like a range selection. Also using indexes, this is pretty much the same thing, remember, as doing lock. You can do a range selection. You can say, give me all the values starting in the index Monday, right, up to Wednesday. And there is a big difference here from what you know already from, for example, Python lists. In this case, both the starting point and the end point will be included. So in this case, we go from Monday to Wednesday, everything included. That's why we get 7, 10, 11. What's the return value? A brand new series, right, that you can start using from that point on. How do you set new values? Super simple. As you regularly know, for example, with Python lists, you will just use the index and set that value right there. So all these things, are setting new values for your series. Of course, you can also set values based on the ilog. Remember, all we've talked up to this point will work with either the regular one, which works with log explicitly, or with ilog, with the numeric position. It's also going to work. So for example, using a negative position as with Python lists, we should set the -1 index, this one right here, to 55. So what you see right here is that this is actually -1, it's going to be -2, and there's going to be -3, blah, blah, blah. Same thing that happens with Python lists. And you can also append, but in this case, the append for pandas series, it doesn't work like Python lists. So if you remember, this is a Python list, append, there you go. You're gonna append 99, print, there you go. The value taking append is a regular value, right? Like a scalar. In this case, in the pandas series append, it's receiving a whole new series. All right, so you cannot append just a regular. I'm gonna duplicate this one right here and try to append, for example, I don't know, 145. It's gonna fail probably. There you go, because the right object. If you want to append, you will want to append another series. So why is this so cool? I mean, where, for example, in this case, the first activity we have is that we have a bunch of values. In this case, they are represented as Celsius temperatures for the city of San Francisco, starting on January the 1st up to January the 7th of the current year. Form them, right, to Fahrenheit degrees. And you can see how simple it is with, for example, in this case, the apply methods. You will see that series, and I'm showing you the same temperatures right here. A lot of these construct apply that will just apply a given operation to your value. Remember that these are also these ones also support the regular scalar multiplication, addition, operations in general. So you could also do something like temps, I don't know, times 9 divided by 5, for example. And I probably, we don't usually do this that often. I'm probably going to get an error here if I don't use brackets in the correct form. There you go. So I can just express this, right, as a regular matrix operation, and it works in the same way. If you check, the results are the same, and if you, of course, try to use Google, for example, to go to check if the values are correct, you will see that they are. And we are performing different operations, and these looks a lot like a regular matrix multiplications. For those folks that are interested in machine learning, for example, this is going to be really convenient, being able to work with matrices and all these just in your regular pandas one. So let's move forward, and I'm going to work now with, there you go, I'm going to show you some selection you can do with pandas series, and this is going to be really cool. It turns out that you can kind of select values by index, as we saw, and position, but you can also use like what we call in this case our Boolean arrays or masks. So I'm going to say that I want to select temps, and I want to keep, and here I'm going to say that I want to keep, for example, Monday and Saturday and Sunday. So I want to keep this one, and I want to keep this one, and I want to keep this one. I don't want to keep these other ones. That's basically what I'm expressing right here. I have 7 values: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. I am passing 7 booleans, true being the ones that I want to keep, and false being the ones that I want to drop. So by performing that operation, right, there you go, we get that subset out: Monday, Saturday, Sunday. The only thing that you need here, again, is just the regular Python series, pandas series, sorry, and passing a sublist with those that you want to keep in true. And why is this so important? Because by default, pandas, whenever you try to make these, so you saw that we could, for example, do, for example, times 9, right? So you have temps times 9, and we usually call this a broadcasting operation, because these times 9, I'm going to show you the regular temps right here. And we're going to do temps times 2, easier to read. So you have Monday 7. If you do this broadcasting operation, Monday is going to be 14, Tuesday is going to be 20. So we're just broadcasting the same operation to every element inside the series. If this operation, instead of being a multiplication, a mathematical operation, is one of these Boolean operators, right, comparison operators, what you will find is that these will actually give you a Boolean array out. It's going to broadcast this operation. It's going to check for each one of them, right, which ones are less than 10. You know, it's just doing that. So it's like doing this thing right here. Oh, it should be 10, less than 10. And let me see if I can, spreadsheets help me. There you go. So here it's going to do, is 7 less than 10? True, or actually X, true, and false, and false, and false, and false, and true, because 9 and 8, they are both less than 10, and 7 is less than 10. Everything else is not less than 10. 10 is not less than 10, just to be sure. So this operation right here, temps less than 10, will actually be also a broadcast operation. But the result of that is going to be a Boolean array. It's going to give you a true-false value for each one of the fields or values in your original series. And you also note, please, that you have also. So that means that we can combine regular selection, like lock, for example, with the Boolean. I can get all the temperatures, right? All the temperatures that are, for example, less than 10. Is incredibly powerful. We do this all the time because you're just filtering your data. We will see how to read data from external sources, for example, from a CSV file. So picture you have with 1,000 lines, and you can perform these broadcasting operations, you know, just to select subset really quickly. So what else? You can also do this selection with like concatenating them with multiple selections. So you can say, for example, give me all that the temperatures are something plus the ones with these given index, which of course is going to be super simple because, okay, so we're kind of filtering everything out there. But that's just to show you. And something for you to keep an eye on is that whenever you are these AND sort of operation, the AND that you're using is not really common and in Python. It's not a regular AND. This will not work. It's this symbol, right? Which again is not really common in Python. It's for pandas to concatenate operations, and this is going to be the OR symbol. So instead of doing OR, you will use this pipe, right? And this is similar to, it's going to be familiar for people in working with JavaScript, express ANDs in this way. So, yep, it's values out of the original series with these. It will also be familiar, for those of you familiar with SQL, it's going to look a lot like traditional SQL, right? So it's just expressing values in the form of regular binary operations and concatenating them with different Boolean operators. Sorry. So, for example, these and that other thing or that other thing. So you're combining additions to get the final values out. And this is going to be a lot like filtering. You know, it's just filtering data based on given values. Make sense? Questions? Just post them in the chat again. We will be keeping an eye on. So in this case, you can see also right there. And now, finally, before we jump to our first activity for you folks to work with, I'm gonna get rid of this. We're gonna work with a data frame, and this is another, probably the most popular data structure used by the pandas library, which resembles, instead of, in this case, a series was resembling these two columns table. A data frame will resemble a table, but with more than one column. I'm going to show you how it works in a second. So we have pressing the different temperatures for 3 cities. In this case, we have San Francisco, New York, and London. So it's San Francisco, all the temperatures here, New York, all the temperatures here, London, all the temperatures right here. And what we will do is build that as a dictionary, right? And create a data frame out of that dictionary. And what you will see is that it gives you like these columns with those values, like all the temperatures in London, all the temperatures in New York, but it's also associating an index. It's saying like this row 0 has these values, 5 for London, -14 for New York, 7 for San Francisco. So again, it's assigning an index. And it's assigning an index automatically because, of course, I haven't provided one. But in this other example, what I'm doing is I'm creating the data frame, and I am indeed providing the index. So now this data frame, it looks a lot like this table, sorry, that we have right here. An index, a couple of columns, 3 columns, and you have a value for each one of those columns per index. So you are again an index which just goes across all the columns you have in your data frame. So again, they look similar because what you will find is that for a Python data frame, this is going to be a series, this is going to be a series, and this is going to be a series. The only thing different is that they will always share the same index. The index is just frozen there. It's going to be shared by all the series. But again, they are just individual series. Something else that you will see is that if you try to explore this data frame in a different orientation, instead of vertically by column, you try to explore it horizontally, what you will find is that this is also a series, right? So you will find series all the time working with pandas. So we've just created a data frame with our data. Remember, our data in this case came from a simple dictionary. We expressed each one of the columns with regular Python lists, and we also provided the index. So we are here. It looks a lot like this table right here. The data frame will also have this describe method that will give you like a really mathematical overview of your data for each one of the columns. And you will also have, and now this is not part of the series, it's only in the data frame, the info method, which will give you information of that given data frame. In this case, it's going to tell you how many entries you have, that index, you know, what that index type is, and for example, the range that it has, and also data columns. In this case, it's going to tell you London, 7 non-null values of the type of each one of those values. So let's now focus on how to select data and read data from these data frames. So the first operation that we will try to perform is column type of operation. We want to select all the values of San Francisco. So in this case, it's going to be something like that. We want to get all these values. And remember that in this case, the index will always be there. So whenever we try to select San Francisco, we're going to get each one of the values for temperatures with San Francisco, but we will not the index. The index will always be there. So what you will get is, for San Francisco, you have these values with these associated index. I'm going to show you that right there. It's going to give you what's going to give you just a regular series. So comparing that to our previous one, right here, it's going to be pretty much the same thing. The name of this series is, of course, the name of the column in the data frame. You can also select different columns, so you can do like a subset of the original data frame. You just get, in this case, 2 columns. Also be, of course, another data frame. In this case, it's just going to be right here. This is what we're selecting in that case. How does the row type selection works? Well, it works in the same way as it was working with regular series. You have the regular lock selector, and now it's a little bit more important to express lock, because if you're just doing squares, right? Sorry, square brackets in your data frame, they're actually usually starting with columns. So now it makes a little bit more sense to use the lock method attribute. Sorry. So you'll do data frame dot lock, and then you're going to provide the given index. In that case, it's going to be that thing right here. And what's the result? The result is a regular Python series, pandas series, but in that case, now the indexes are these cities. So you are kind of inverting those. So you have now San Francisco, it's going to be 7, and New York City, it's going to be, and London, it's going to be 5. So you're getting this series out, because again, you are selecting by this index. What you will also see is that all the other operations just apply, for example, the range, but you can also combine index selection with regular column selection. So you, instead of saying, I want to get all the values of Monday, but you will just get all the columns, you're going to say, I want to select the values of Monday, but only New York and London. So in that case, you will get just those 2 columns out. Also select, like with traditional collections or sequences here, specifying a bunch of indexes and columns, or you can also do range, for indexes and columns. Everything works in the same way. The same thing happens with filtering and conditions. So for example, you can select all the values in the data frame for which the value is less than 10, and now it gets a little bit trickier, because in this case, this operation is kind of recursive. It's like pandas is iterating over each one of these values, right? And it's selecting the ones that are less than 10 degrees. So for example, I don't know if it's data frame is less than 10 degrees. It's not working as expected.
Why? Negative is less than 10. Not absolute value.
Because yeah, I'm getting the San Francisco one. There you go. So now I'm selecting the values, and I needed the index. This is the one that is going to work. I'm going to delete this one right here, because that doesn't make sense at all. So in this case, we are selecting the indexes, right? So we need to always kind of isolate these rows, right? But a given condition. There's just the data frame less than 10 was an ambiguous question to say in a way. So that was the result being bad. So in this case, San Francisco is going to be, the values for San Francisco that are less than 10. So in that case, is going to give you, in this case, we have, it's not working either. What's my original data frame? We're having a few technical issues. So to show you again the source of data right here, we have this Boolean array right here, and what we want to get is San Francisco less than 10. So there you go. True is less than 10. I'm doing something really bad. In 64. All right, I'm gonna review it later. We're using the lock is gonna work now better as expected. And in this case, you're also selecting columns as you already know. So what you've seen in this case is that sometimes these values will be replaced with not a number. And that's actually a NumPy value. Let me see if I can import NumPy right here as NP. NumPy will have this value that it's NP dot not a number. And this is a special type because it's not 0, it's not null, it's not none, it's not a number. And what you will see is that it's sometimes a tricky value to work with because it's kind of a virus, you know. It's if I do, for example, not a number times 3, it's not 0, it's not 3, it's not a number. So if you're performing operations and your data frame or your series, your data in general has this not a number, again, it's going to affect pretty much everything. So usually you will want to, by the way, I have a data frame right here, so I can show you. There you go. I'm setting a few not a numbers right here. By the way, I'm using none, but pandas is transferring that, is transforming, sorry, each one of those nons to actually not a number from NumPy. But again, performing operations with not a number can be tricky because as I showed you before, right here, np.nan, +3, you get always not a number. So again, it's kind of contagious, so it's better not to use it that often or for computation. So a regular operation that you will want to perform is for example, to remove these not a numbers or these values. And with an external data source, for example, reading a CSV file or an XML file or an Excel file, you will find these empty values. And for that, you can use these methods. For example, the regular drop not a number. In this case, what you will get dropped are right for those indexes that have actually a not a number. But you can also perform a different type of selection with the columns, and that's what I told you, that we've had like 2 indexes when we were, or 2 axes, that's a better name. So one, the default one, is going to be the row level axis, this one right here. So the regular drop is going to work with these row type of axis. But you can also specify a vertical column type of axis. In this case, it's going to be this one right here, and that's with axis 1. So it's going to drop all the columns that have at least 1 not a number. So that's why New York is the only one with, there you go, right here. New York is the only one without. And something that I showed you before was that pandas is pretty much all the time performing operations without modifying the original data frame. So if I just reload the data frame, changed. These operations will return a new data frame, for each one of them. There is actually some of this method will have this in place value, indicate that you want to modify the original data frame, but by default it's going to be false. If I do that now, you will see that now that I'm going to create a new one so we don't execute the same thing again. Now we have indeed dropped those values in place. So this is a general conclusion or idea for they will perform immutable operation except the times when you explicitly say that you want to modify the original ones. Given those not numbers, let me create a few more again. I'm going to create the whole thing just to be sure. We're going to add these ones. I'm going to see. There you go. And you can also perform a fill method, which is really convenient, especially when working with numeric data, because you can, for example, even whatever value you're provided doesn't have to be numeric. So in this case, we're filling the non-numbers with 999. Or you can also specify a different, like filling the values with the, in this case, let me show you the data frame again. For example, filling this one with the previous one. So it's going to be 2.0, it's going to be placed here, right? So that's going to be a forward fill because you're like overflowing the values to the next ones, right? So you're passing this one here and this one here if value. Or you can also do a backward fill, you know, it's going to be a different type. In this case, what you will note is that 9 was placed in this value, right? So 9 filled this value, but these two are still blank because there is no value at the bottom to backfill values, right? So that's the important concept right there. All right, questions? All right, so I think we are ready for you folks to start the first. Oh, no, sorry. We have one more notebook to show you, and it's a really interesting one.
Question.
Yeah.
Can you show how to fill with median?
How to show with median? Yes, you will have to just use fill, traditional one, fill NA, and here you will have to provide a value. So you can do something like 9, right? It's going to fill with that. So in this case, you will just do df.mean, right? It's going to fill with the mean for each one of the values. In this case, describe again. Describe. There we go. Sorry, my bad. So you see that the mean of London is 4,125. So the not a number. This one, Monday 2, was none. Now it's 4,125 because that's the mean of London. And for San Francisco, the mean is going to be 971. It's going to be used for these last two values right here. So you'll have to provide, you'll have to do the actual, or pass already the actual value. The mean, I don't know if I show you these. For data frames will also be a series with the index being the columns. So in that case, that's how it works. So matching the right column, because again, we're passing the indexes as columns. So we're going to show you how to read external data. And for that, we're going to use these CSV or these, yeah, it's originally a CSV file. You can get right here. We have this tab info with the origin of this data. Copy is blank, completely blank. I will be modifying this one, so it's just in case I'm keeping that one. And we will be importing this data into pandas. You will see how simple it is to get data right here. So what I'm going to do is just import pandas, and I'm going to use the method CSV. Right, so that read CSV is going to receive a given, just an argument, a path, and that's gonna give you, right, the CSV import I'm gonna just show you. I'm gonna use the head method that we didn't use before, because head is, of course, is gonna show you the first 5, the first 10 records, and we didn't need it before because we had like a few records. But in this case, we have how many? I don't know. Oh, well, a bunch of Pokemons. We have like 700 Pokemons. We will need, of course, we could, I can actually do it. Full data frame, you will see that's kind of an endless scroll. So you will usually do just head and get a bunch to analyze that data. So what's going on here? We see that this external file has already what looks like an index. This numeric thing symbol here, this pad, this hashtag right here, it looks like the index. But Pandas is not considering that to be an index. It doesn't know about it. So it's just reading it as a regular column. So what we will do is just say to Pandas, to the data frame, that that value right there, it's actually the index with this operation. So I'm just doing that. And I'm on top of that just renaming it, because just having the pad sign there isn't really good. So I'm just going to now explore the data frame again. Index is now this ID one that was actually from this original column.
Hey, we got 2 questions real quick.
Yep.
We got a question. They wanted to know how to get the mean for just a single column on that last one with the temperatures.
Right here.
Yeah, like for just one city, like how would we get the mean for that? Okay.
Important in this case for everybody. Remember that Pandas will go back. It will go back and forth to the 2 main data type or collection types that it knows: series and data frames. If you perform this operation in a data frame, but you get it's a series, and you already know how to get the mean of a series because we showed it before, so you will just select a given column and then you mean, and then do mean on that. So again, whatever you select, it's going to be 0, and that's going to give you another series. It doesn't make sense to like average all these temperatures maybe, but again, it's just a series.
All right, we have one more question for the. Does the read CSV work well with UTF-8 data?
Yeah,
okay.
Yeah, it does. It works, and this method is like really powerful. Let me go the more. There we go. So this method has many things, and we're going to show you a few more. But you will see that there are many things here that you can customize for whenever you're reading data. Right now, you will be able to customize the type of the encoding. You will also be able to customize to create converters, or just encoding, etc. for your data. So the delimiters, sometimes CSV is a general term, comma separated value, using tabs to separate values, or pipes or other characters. So you will of course be able to separate those specify those. Now, something that we didn't show you enough before, and I think it's important, is that again, each one of these, if we describe these, info these, you're going to get that each one of these tuples, or a series or columns, they have an associated type. So for example, total, it's going to be int 64, right here. And you will see that if they are legendary or not, that's a Boolean type of array. If they are the name, it's going to be an object type of array. That's actually a string. Well, there are different types with pandas, and we want to show you really quickly one that we use all the time. Is the category type. It's usually also called categorical because of the way pandas call it. So now if I show you the types of your data frame again, what we've done is transform type 1 to be category, with the type method. And these will have implications later. First of all, it's saving you a bunch of memory because it's just like internally assigning a numeric index here. It's going to say, for example, grass they will always be type 1, 1, 1. Far is going to be 2, 2, 2, 2, 2, 3, 3, 3, 3, 3, etc. And it's keeping in a separate place. As 2 is fire, 3 is water, etc. So it's saving you memory. But on top of that, you will have different ways of counting values. So, for example, this one will work better with category types. And also, in this case, if we describe it, it's going to give you the frequency of each one of the values that you have. And for example, I don't know, some important information that you can, of course, get later. Everything is going to work in the same way. So where, for example, grouping by a given type, this doesn't have anything to do with the categorical or the category type. Group by a given column. So we're grouping type here. So we have, for example, all the grass Pokemons, right? If we put them all together and what we're using, it's no column, then we're gonna get, for example, we're getting the mean of that each one of those columns. So if we kind of combine all these grass Pokemons and we get the mean out of the, for example, the max or the sum, you can do whatever. So the max attack a Pokemon, that's the question. What's the maximum value of attack per type of Pokemon? So it's going to tell you that bug Pokemons have the max attack is going to be 185. I don't know. Psychic is going to be 190. Have different values, or you can perform different aggregation operations by grouping by those columns. So all these some regular aggregations, they are all going to work in the same way. Once you group by, you can of course make a projection in a given column out of that. So in this case, we're getting all the Pokemons grouped by type 1. We're selecting only attack, getting the maximum, and then sorting the values. So the less attack to the most attack, we can also do the other order, ascending equals false. We're now having the maximum at the top, and you have the max value per type. You can, of course, help with the spreadsheet, but the results should be. So all these operations we perform, you can, again, the read CSV method is super powerful, and we encourage you to take a look at the documentation later. But basically, you will be able to provide many of these things. So for example, you can read the CSV case, right? Tell pandas which one is the index column, and also provide a mapping of the data types. And it's going to be also interesting whenever you're parsing data frames or CSV files with time series or time data, because you will tell pandas to parse the dates expressed in your data frames. Work in the same way. So for example, we're going to get, in this case, we're doing a type of filtering selection. Documents where the type 1 is fire and type 2 is flying. We get these Pokemons out. This is just regular data framework as you know it before.
We did have one question. How did you pull up that menu for the read CSV thing to show all the different options?
Yeah, so right here, you need to do Shift Tab. Right, so it's going to be Shift Tab. That. There you go. And if you hit it again, it's going to give you bigger look. And if you hit it 3 times, it's going to give you the bottom one to show
Does
you.
this read Excel files as well? Do you do like read underscore Excel or?
Yeah, I think it is. I don't read. Let's expand this. Sorry, I don't use it really often. So yeah, it's pretty much the same thing. I don't know what's using underneath, to be honest, to parse the ones, because you usually what I do is use CSV kit, go from Excel to CSV, and then use CSV from pandas. I don't know why. Maybe I'm old-fashioned. I know CSV kit a lot, and it's a really good tool. Something else that I wanted to show you was devdocs.io. So for example, devdocs pretty cool. You will get, for example, read CSV. There you go. Information right with a fussy search. All right. Activity time. We want you to have the chance on your own. All right. So we're going to use the Pokemon activity, Pokemon data located under part 2 interdependence. Try not to pick the solutions there for now. And we want to give you, we want you to find the strongest Pokemon as max attack, the weakest one, and then a few more here. So for example, we want you to find Pokemon type, so the ones, for example, grass poison, we have 4 grass poison, and we have 2, the ones I see right here quickly, right? So combining these types, which are the ones, which are the most common ones, and for that you have to be careful checking Pokemons with type 2 blank. So for example, these doesn't count because type 2 is blank. And finally, 2 more. The most powerful Pokemon by type 1. Some hidden gems for your Pokemon hunt. Which ones are those that are more difficult to get because they are, oh, sorry. There we go. So the less common one. For example, the type Fire Dragon is only once found in this data set, at least, and that is of that type. So those hidden gems, that's your task right now. What we're gonna do is just give you 10 minutes so you can solve these with your own notebooks, and we're gonna show the solutions after that. All right, so those of you who don't want to work, just take 10 minutes off, and we're gonna ping you all in our Slack channel in a few minutes. Sounds good?
Some of these things are pretty advanced, so don't get frustrated if you don't get them all.
Yeah.
At least you get the solution soon.
True. All right, let's get started with the solutions. All right, we're resuming the workshop. Took a few minutes off. Get back here. Yep. And so I'm gonna, where is it? Right here. I'm going to start with the first one, and someone pointed out it was kind of confusing, right, or ambiguous to ask the strongest Pokemon by attack, and that's because whenever you're dealing with data, you cannot be sure something is going to be truly unique, right? So in this case, I think we're going to have a unique value. But for example, you can have, I don't know, if attack, the greater, like the maximum value of attack is 200, you might have n Pokemons with 200. So there is no one strongest Pokemon. What you will find is the biggest value for that particular column, and then you will find all those rows that have that corresponding value, right? So that's what's confusing in that case. We are probably getting too deep into the data we're handling, so we know that there might be one strongest Pokemon. Usually it's important to understand what you're trying to look for. So if we just read our Pokemon data file regularly, what I'm going to do first is sort all the by attack, and I'm going to get the first 5. So you see that there is actually one strongest Pokemon, the one with attack equals to. And to get that value out, you can, of course, do something like 0, you know, and, oh, sorry, 1, not 0, and get something like index, you know, and not that convenient. Usually, I'm going to get the. Usually, what you will do is, first of all, try to compute. I'm going to use another row here. The maximum value of attack. Again, several Pokemons having that value. The first thing you want to spot on is what's the maximum value of attack. And actually, confusing, and it's common to get tricked by this fact. Because again, usually we start with the index that we want to get in, to say it in a way. We say, give me the strongest Pokemon. So you're thinking about a Pokemon, saying about the best performing student, you know, with the highest score. You're not looking for the highest score of students or the strongest Pokemon. But the first thing you have to ask yourself is, but which one is the highest score between all the students? And that one, I don't know, maybe it's a 10. 5 students with that highest score, and maybe you have to use a second value, you know, if you want to somehow filter it down to just one student, you know. So in this case, the first thing you have to find is the maximum value per attack. In this case, is 190, which, as we can see right here, corresponds to this Pokemon. So then you will say, give me all the Pokemons that have that value by attack. And again, if we would have repeated values for attack, we will get 2, 3, and given Pokemon. The same thing is going to happen with the minimum 1. We will just get the minimum by attack. And now you can see that there are 2 Pokemons that have an attack of 5, you know? So poor guys, these are peaceful Pokemons. Do a few more that are interesting. What are the most common Pokemon types? So again, we won't consider these values, the ones without type 2. So fire flying, fire dragon, fire flying. And if we just look at this view, whatever I can see here in my viewport, I have 4 grass poison Pokemon. So these are definitely the most common type, because again, they're repeated 4 times, 2 times for fire flying, 1 for bug flying, fire dragon. But of course, we want to check the 800 Pokemons. So how we're going to do this, I don't need to rewrite the what I'm gonna do is combine both Pokemons, right? So I can do something like combine both Pokemons. And if I show you, what I've done is I've created a new column. I'm gonna do actually head here, head, and we're gonna see the first 10 ones. I've combined the type 1 and 2, right? Column. So I have this combined type, which is grass poison, and it's just a string, right? Grass dash a poison, the second type. In this case, what I'm doing is just using a regular string formatting and using apply to apply that transformation function to each one of the Pokemons right here. And again, remember, you have two axes whenever you're working with your data, and this is probably easier to see here. You can work with your axis in terms of column, or you can work with your axis in terms of rows. So what we need in this case is, oh, wrong. There you go. So what we need in this case is to work in these axes, the axis of rows, which again is the number 1. So we are combining types, and we're getting each one of these P arguments right here is going to be one row of Pokemon. So I'm getting type 1, type 2, and combining the whole thing in a new column, combined type. So now you see that we have grass poison, we have fire, not a number. That's because, again, in this case, this is going to be not a number for pandas. We will, of course, not use this one later. Dragonfly, fire dragon, sorry, etc. So once we have this new column we have just created, what we will do is make a special formatting. So what I'm going to do first is I'm going to show you how can I show you these better, separated in several parts. So the first thing we're going to do is get 10. Get all the Pokemons which the type 1 is null, is not null, and we're negating this. So this is another way of thing that isn't a null value. You can also have sometimes is NA, is also part of the new standard library of pandas. And you can just filter things saying those Pokemons which have results or values for both type 1 and type 2. So what you will see here is that none of these Pokemons will have type 2 blank, right there. And then the next thing we do is we group them by combined type. So what we're going to do here is combined type, right there. I'm going to, of course, oh, in this case, it's a group by data frame. So it's going to count. Let's just do down, count. You're going to get the ones, I mean, you will get a count for each one of the types. This is similar to SQL. If you've worked with SQL before, this is being created. If you're expressing an aggregation, you're projecting too many columns, you're going to get all the values repeated. So these are all repeated. But you can clearly see here that you have many different types of Pokemons. So for example, bug flying, we have a bunch. Bug poison, we have a bunch. So we're probably going to see them at the top. So what we're doing next is just sorting these values. Ascending false. Whoop, by, I'm going to sort by, sorry, my bad. I'm going to show you that thing again. I'm going to do sort values by, it's pretty much the same thing. Let's do by name to make it simple. And now you get normal flying 24, grass poison 15, bug flying 14, right? So this is of course the most common type. We're closer to our what you will also see is that you have a bunch of types. You know, there are many with one, but you have 136 unique combinations of, not unique, combinations, sorry, of types. So combinations of types, you have also a bunch. And finally, you can just get, of course, the first value here, head 1, and index, for example. You get its normal flying is the most common type of Pokemon. Pokemon defined by total, we did something similar before, the data frame, and it's simple. You will get first all, like, the maximum type of Pokemon first, and you're just performing an aggregation on the total column right here. The only different thing is that we're going to use this transform thing, that this is new. Transform one that it's similar to apply. Remember, we've used apply a few times. This transform one is used for aggregations, and what it's going to do is it's going to attach. So let me show you the Pokemon. So for example, you have, all these are grass poison, and if you group by type, by type 1, it's going to say that all the grass Pokemon, from all the grass Pokemon, the largest one by total, it's going to be, let's find it, 630. So what this transform is going to do is pretty much adding a new column that says 630, 630, 630 for each one of the grass Pokemons. And for fire, for example, it's going to attach next to it. We're going to modify it here. It's going to do, find the max for that type and add it next to it. And what's the biggest one by fire? 680. It's going to add 680 to fire, 680 to fire, and fire and fire. So it's kind of putting next to the data the value of the max by type 1. Max total, I think it is, by type 1. So that's gonna, and I'm gonna show you here what that data frame looks like. And as I showed you before, it's most powerful per group, right? So you have, let's show a few more rows. You have grass poison, it's gonna have 630, 630, 630, 630 again type. So we have there the Pokemons, and next to it the largest value per the group. The thing that we have to do is selecting those Pokemons which their total is equals to the total of the most powerful one of the group, right? So we just need pretty much to equalize or to compare next to, like, side by side. So if let me show you now, sort values by total. False, head 10. So now, for example, these, I don't know how to pronounce this thing. These Pokemon, my knowledge of Pokemon is up to generation 1. These Pokemon has a total of 780. And it happens that type, the dragon type, 780, it's actually the most powerful value. So this means that this is a really powerful Pokemon in its own group. So we will want to get this one right here. So the only thing we have to do then is just by type, right? So give me all the ones that have the total is equals to the most powerful by group. As simple as that. And then what I'm doing is just grouping by type 1 and getting the first one. Because again, we want to get 1, but there might be repeated. Finally, the ones that are less common, it's something similar. We're going to perform this operation again, combining the Pokemons with, I'm going to do df.head. So we've combined the type of them. And then what I'm doing is I'm just dropping the duplicates. I'm dropping duplicates. Remember, we were able to, let me do something like df.drop NA. Well, we can also do drop duplicates right there. Drop duplicates of right here, combine type. What it's gonna do, and let me see if we can find anything interesting here. Fire, not a number. We have fire, yeah. So if I show you, sorry, I'm gonna do df.head 10, head 10. So what we see is that Charmander and Charmeleon, sorry if I'm pronouncing this wrong, far not a number. By default, if you do drop duplicates, it's gonna keep the first occurrence, but all the other ones after the first occurrence, they will be dropped. So you will see here the Charmander is right here, but the second one, or after that repeated one, it doesn't have to be consecutive. They can be in any order, will be dropped. You can change that, and actually I can show you the documentation of this. You can use the keep value right there. You can use the keep value to found or to keep the last one found, or just drop all of them. So drop all the duplicates, and that's what we're doing. So we're going to use keep false here to drop all the duplicate Pokemon. So here we're keeping these unique combinations of Pokemon. Right there, that's the way to find these unique types. Questions? All right, so this is getting a little bit more quiet. I guess people are going to sleep. It's a good thing, actually. So finally, I'm gonna do this really quickly so you are all released from the nightmare of pandas. And I'm gonna show you really quickly the API of matplotlib. Ideally, I mean, this is also recorded, so ideally you can also check it later in case you are kind of fried up to this point. Really cool library. We use it all the time. Pandas also use it. It's kind of integrated into pandas, and we want to highlight this particular library because it actually has different ways of working, and it's based on MATLAB, and it's based on older tools that were used for, they're actually still used, but they have different and weird APIs. APIs, it's like the term we use for the interface that we will use with the library. So there are different ways of interacting with matplotlib, and usually it's a source of confusion. So that's why we want to talk about it today. When I use matplotlib, you can just import it. You will usually import pyplot, the module pyplot, and we reference it as PLT. And then we're going to use this function of that will allows us to charts right in the notebook. So I'm going to import this. I'm going to create a simple NumPy array, right? So I'm going to create, whoop, there you go, the warning. I don't know what we have warning there, but it's not a big deal. It's still executing. There we go. So we have now, I have created a regular array with values, and I also have those values squared. So if I show you y, you will have those values squared. And we're going to start using the matplotlib API to plot things. The first thing, we're going to use regular plt.plot. Remember, this plt comes from matplotlib.pyplot is a module. And I'm just do plot right there. And you get a nice plot in your Jupyter notebook right there. this is actually an image. You will be able to save this image as a PNG, as a JPEG file, etc. This plot thing accepts so many different configuration options. So for example, you can decide the color of the line that you're using, or actually line of the indicator, and also the type of indicator you're using. In this case, I'm using dots, right? O, or I can use dashes, right? So you're you're using a different type of style, right, for your lines if you want, or for your values. The color, I can use red, and again, this is similar to to MATLAB. Matplotlib will have two different big APIs, and that's how all these things started. And again, this is what we try to help you so you're not so confused. The first one is this one that we're using right now, and it's a global API. That's the way we call it. Some other people will call it functional API. It's not a functional API. So it's a global API. What is happening is that you perform will be kept like internally in Matplotlib in a global state. So they will all modify the same plot. So for example, what you see in this next row is that I'm creating a plot. I am setting labels for the X values and for the Y values. And I'm also setting a general title for the entire figure. I'm going to do that and show it to you. And you will see, right, points in the X values, values in the Y axis, sorry, axis, not values, and quadratic function in the title. How does Matplotlib know that this thing corresponds to this one that you created before? Again, because it's using global state. And then any other operation you perform after that original plotting will affect that plot. And that's sometimes confusing, and actually it's not really good. If you know about Python, those of you that have done our course, you know that doing or using global state isn't recommended. If you can also, of course, I don't know, do several plots. So you're invoking plot different times and you are plotting on the same figure, right? So everything again is affecting the same global object that you're using. Different type of plot, completely random, just showing you something different. Instead of doing just plot, you can use bar, you can use bar H, you know. Oh, in this case, I'm combining different plots, not gonna work. What happened? Oh, I can't. So let me remove these really quickly. So you can also, different type of plots, pie plots, scatter plots, all of them will be available. Global API. The other type of API we have is the object-oriented API, and this is actually the recommended. And this is important. This is what we try to highlight. The way it's going to work is that you will create these figures and you will start creating these axes, and this will give you full control on what you're currently drawing, right? So in this case, you know that, for example, this X label affects the previous plot that you were doing. But again, that's not explicit. It's kind of implicit because everything is being kept in the global state. In this case, we're going to create a figure. We're going to create a set of axes, and we're going to use these objects, these regular Python objects as references. So we're going to, let me start here. I'm going to actually start showing you these right here. And what you do is you first create a figure, and that's the general canvas, to say it in a way. It's like this red thing. I'm actually setting a face color so you can see it. This red thing, whatever is at the bottom, you can say that's a canvas. And I'm also giving a figure size. And then you're placing an axis. So you're doing add axis, and you're placing an axis with these coordinates, which are basically left, bottom, width, and height. right? So those are the values you're providing. And then once you've set the axes, as you can see, my axes are right here, right? The axes are, of course, these blank, this white canvas with the lines, right, and the numbers. You will start plotting, but in that case, you are, of course, referencing those axes. So you're not just saying plt.plot. You're saying, I want to put a plot in these particular axes. So you are extremely explicit on which place you want to set your plot. So in this case, I am plotting the same values as before in these axes. And similarly to what we saw before, for example, here you were setting X label or Y label, right? Generally to PLT. In that case, you will use axes, and the method is going to change a little bit. It's going to be set X label, set Y label, and you will provide here the labels. Point values, as you can see right here, point values. And also I'm setting a title, right, for the entire figure, for entire axis, sorry. And I'm setting the legend for, in this case, I have only one line. If you have more, of course, it's going to be convenient to place those. What you will also see is that you can add several axes. So this is going to start looking a lot more, I don't know if professional, but powerful, right? So in this case, I have a big axis set, right, with places 0, 0, 0.9, 0.9. So width and height, again, they're pretty much taking the whole space. And then I'm setting a new axis, this tiny one, which is in position 0505, percentage of the image, left bottom 0.05, and the width is going to be 0.3, and the height is going to be 0.2. Right? So I'm setting a new axis on top of the biggest one. And I can, of course, I could do something like a1.plot xy, right? And I can do a2.plot x, I don't know if it makes sense now, x, x, right? So you can plot different things in those different axes. But again, the object-oriented API is going to let you say where you want to plot. I want to plot this thing in these axes, in this set of axes. Something you will see is also the subplots call. So instead of manually creating a figure and then setting axes, you can just use the subplot method that will create the figure and the axis all at the same time. And also, it will let you create these subplots distributed on an organized way. So in this case, you're going to say, I want to create 2 rows of plots with 4 columns of plots, and it's going to look like this. So we have 2 rows of plots, and you have 4 columns of them. You have 2 times 4 plots. And what is this axis thing? It's just an array. So the first row is right here with the 4 plots, and then you have the second row right here with all the 4 plots. And again, you will say, for example, I want to plot something on the plot in position 0, 1, right? This one right here. Or you can just iterate, right, and provide titles for each one of them. So for example, chart 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, etc. It's just a regular one. What I want to show you is that these subplots, it's really convenient because it will let you create all the plots you want and just create figure and axis all in just one call. Usually, you can just do subplots without passing many rows and columns, and it's just going to create one axis and one figure. You can see also different type of plots to play with later. You also have these visualizations as practice for the Matplotlib part. We are gonna finish the YouTube streaming, but you are encouraged to keep working on this. We'll be around so you can practice with matplotlib. All right, what we will ask you to build is this simple pie plot. You will have to Google how to do a pie plot, but just for you to know, it's going to be super similar to what you can see right here. And of course, you will have to combine that with the data analysis activities we did that were, for example, grouping by Pokemon, right? So grouping by Pokemon, and you're going to do something like df at group by, for example, you can do, remember, did we do a group by here? We did it. Yeah, we did it right here, group by. So you will do something like group by type 1 dot count, right? It's going to give you a count of each one of the Pokemons you have in that particular type. Be aware, in this case, you're going to get this interesting. We didn't see it before. Type 2 gives you a different value for count, because in this case, it's not counting not numbers. So be aware, if you are, for example, getting a percentage share of how many Pokemons are type bug, right? You can do something like of type here, type bug. Whoop, I did it wrong. What's the error? Dot lock. Yeah. There you go. 9, right? It's gonna be at. We're gonna do something like name to get a given value, divided by the total of the F. So that's gonna be kind of the percentage share of bug types of Pokemons. Be aware that if you use type 2, you will get a different value, because again, we're not, if I show you, type 2 has not numbers and they're not being counted as part of the total. What else? Let me see if charts.png. I don't know if I don't know if so there is a save PNG, save fig, sorry. It's not part of the docs. I don't know, sorry, I should have checked this. I don't know if it's gonna work properly on the Azure notebooks. It should. But there is this save fig method that will let you save a given figure, right? In your, sorry, as a regular image, so as a PNG file or as a JPEG file. So just check it out later. You will just do save fig, and you will do, I don't know, my image .png .jpeg, and just by getting the extension of the name you try to use will guess the final type, and you can of course customize it however you want. Because usually, I mean, looking at them in the notebook is fun, it's interesting, but you sometimes want to build real life reports. You have to export your images. All right, so visualizing Pokemon types, again, as a pie chart and as a bar chart, it's interesting for you to practice after this thing. Amy, yeah, it's an open source API library. Yeah, definitely. And something I didn't show you, and I will do it right now. By the way, I know we're kind of exceeded with the time. You're more than free to go. Instead of doing matplotlib inline, you can do matplotlib notebook. And it's gonna be interesting. I'll show you why. Well, it's not working in the Azure notebook. So if you try this locally, have it right here. Plot live. Yeah, right here. Sorry, this is a local. It will give you an interactive. It's not working. Why isn't it? Is it Notebook? I have to double check this. It's going to be an interactive way of working with these plots. I don't know when it's not working. It's Notebook. And there are other visualization libraries. Especially, I like to point to Seaborn, which is, it works on top of matplotlib, but it's specially used for statistical visualizations. So all like box plots or scatter plots, like heat maps, it's so simple to create them with Seaborn. So just for you to know, it works on top of matplotlib. It will let you export all your images and your charts. So simple for you folks to work with if you're interested. All right, so I think that's it. Thank you for those sticking around so late. We'll see you hopefully soon. And if you folks are interested, let us know, and we will keep doing these workshops later. And as I told you before, hopefully we can have a little bit more time during a weekend. All right, so have an amazing night. Jason?
And this recording will be available, correct?
Yep, it will be available later. Do you want to wrap it up?
You had it. That's it. That's good.
Good enough. All right.
Yep. Thanks everybody. I guess just thanks everybody for stopping by. Hope you liked it. Hope you enjoyed Santiago's crazy teaching. Yeah, we hope we can do more of these kind of things. So let us know if you liked it. That's it.
Good. Have a great night.